Tower, Aircoup 99055, Mayday, Mayday, Mayday.
Aircoup, Midway, go ahead.
Yes, this unique vehicle you are watching is a Pulsejet engine called Buzzy Bump because of its buzzing sound. Pulsejet engines are the first gas turbine engine examples produced in the past century. Although the development of Pulsejet and Ramjet continued parallel to each other, Pulsejets met faster with the sky. Although Russian scientist Viktor Karavodin, French scientist George Marconet, and Spanish scientist Ramon Casanova had done important studies on Pulsejet, the first realistic Pulsejet engine was developed by German engineer Paul Schmidt. Paul Schmidt examined the Pulsejet models introduced by scientists before him and developed the Argus Pulsejet engine in 1942 after long studies. Later, the Argus engine was mounted on an aircraft fuselage known as the V-1. Pilotless V-1 aircraft, considered to be the ancestor of cruise missiles, were first used in World War II. The Argus's first starts were used acetylene as fuel and a spark plug to ignite it. The plane needed a catapult mechanism to take off. Before the aircraft was launched from the catapult mechanism, high-pressure air was being supplied to the engine inlet, and the first ignition was being made. The V-1 rocket attached with Argus was being launched. Pulsejets don't have rotating parts. The engines are basically designed in two types, with and without valves. Let's get to know this unique engine better. It is the single-wave valve system, the symmetric structure that allows the valve Pulsejet engine to operate. It is operated according to Lenoir cycle. The air taken into the engine passes through single-wave valves and enters combustion chamber. When the incoming air reaches the proper pressure and its speed drops for combustion, fuel is sprayed into the environment and combustion is started with a spark plug. With the start of combustion, the increasing volume and pressure in the combustion chamber causes single valve to be closed. Burnt gases, which cannot move towards the inlet with the closing of the valves, are forced to exit from the narrowed nozzle by directing backwards and occurs thrust. When the combustion process is finished, the vacuum created inside allows the valves to be opened again and the atmospheric air to enter the engine. This process is repeated about 43 to 45 times per second. Pulsejet engines' advantages are that they are light and cheap. Disadvantages were noisy and not being able to reach very high air velocities. The valveless Pulsejet is much simpler and the oldest known jet engine. They work on the basis of pressure difference occurring as a result of combustion inside. Valveless Pulsejet work on the same principle as valve Pulsejet. However, this type does not have a mechanically controlled valve. Instead, the blockage application of the exhaust gases to the incoming air at the combustion chamber outlet acts as a valve. These engines do not require forward motion to start, but must be provided with air for the first start. When the combustion is initiated, the burnt gases move through the wider channel towards the exhaust. The low pressure or vacuum situation that occurs in the combustion chamber as a result of combustion causes atmospheric air to enter the combustion chamber again. Although the atmospheric air entering the combustion chamber wants to pass to the exhaust. The high pressure in the exhaust acts like a valve and does not allow atmospheric air to pass towards the exhaust. This situation causes the pressure of the atmospheric air taken into the combustion chamber to increase momentarily. Meanwhile, fuel is sprayed into the increased pressure air and ignited. The burning process is repeated multiplied times in 1 second intermittently. Propane or the same type of flammable gas can be used as fuel. Advantages of valveless PALJet engine: it is easy to manufacture and can operate with minimal maintenance throughout its lifetime, since it does not have valves that need frequent replacement. Disadvantages of valvejet engines: they produce less energy than valve PALJets. Energy losses are high and air velocities are very low. Usage areas of valveless PALJets today are model aircraft, experimental go-karts, cruise missiles, and target aircrafts.